Okay, so now we're going to begin with solving linear equations, which is the first type of equation that you should know in grade 10. So here, as you can see, we have a number of questions, and with these number of questions, I have highlighted the green ones to signify that those are the ones that you will see in this video. That will be an example. But then the red ones are the ones that I would like for you to try out on your own. And if obviously you have problems, you should ask, and hopefully someone can help you. If not, you can send the questions through to us. Okay. So the first one is minus 2x plus 6 is equals to 18. Now remember, equation is something that is not new to you, but it's something that you've been doing for quite some time now, since grade 8. The same procedures and ideas still apply, that what you do on the left hand side you must do on the right hand side, meaning that when I take plus 6 and I subtract it from this side, so I'm subtracting minus 6, I'm not writing it yet. I am in a way subtracting it from one side and subtracting it on the other side, you see. So I'm actually doing it on both sides. So in actual fact, what you find is that it's 18 minus 6, and 18 minus 6 is 12. But because we are not solving for minus 2x, but we are solving for x, then we divide by minus 2. So it's minus 2 x divided by minus 2 on both sides, and 12 divided by minus 2 just gives us minus 6, and that is our answer, right? So don't forget, this cancels each other out, and then we find the answer. So it was very straightforward. These are linear equations. But this is where it gets a bit more complicated when we look at k. Now when we look at k, it has fractions, and I would think that most people do not like fractions. However, there are two methods in which you can do this fraction question. But the first one is the best one that I think. It's more simpler, more straightforward, and more flowing. Okay, so here you have 2 divided by x minus 2 plus 3 divided by x plus 2, and it's all equals to 4 divided by x minus 2. Now here the whole point is that you need to choose a lowest common denominator, and the lowest common denominator in this case is basically x minus 2, x plus 2. And another way of thinking of this particular thing here, if you don't remember what a lowest common denominator could be, you should rather think of it as, what are the two products or two factors that I can put together, that I can multiply across everything that will simplify it in such a way that it becomes linear, right? That it will get rid of the denominators. So here it's x minus 2, x plus 2. Now if you think of it, x minus 2 and there's x minus 2. If you multiplying this entire thing to this singular one here, which is the distributive rule, remember, one at a time. So when you multiply this one once, so you take x minus 2 and x plus 2 together, you would find that x minus 2 will cancel out with this x minus 2, right? But then what you'll be left with will be 2 and x plus 2. So that's why you have 2x plus 2, right? And then again, when you do it again, you take the entire thing again, which by taking the entire thing, I literally mean that you will take x minus 2 and x plus 2, and then you multiply to 3 over x plus 2. Now you have x plus 2 here, so x plus 2 will cancel with x plus 2, but then you'll be left with x minus 2, and x minus 2 will multiply 3, so it will be 3x minus 2, right? So that would be 3x minus 2. And then on the other side, same thing applies. On the other side as well, remember, what you do on the left hand side, you must do on the right hand side. So again, in this case, you have x minus 2 and x minus 2. So these two will cancel out. You'll be left with 4 and x plus 2. So it will be 4x plus 2. And then from there, you know distributive rules. You apply distributive rules throughout, and then you solve the equation. So you find 2x plus 4 plus 3x minus 6 and is equals to 4x plus 8. And after that, when you do grouping, you'd find that it would be 2x plus 3x is 5x, 4 minus 6 is minus 2, and then you here it was already 4x plus 8, and then we take 4x and subtract it to 5x, which just gives us x, and then we take minus 2 and we add it to 8, that gives us 10, and so that would be the answer. So as you can see, this method is quite seamless, but alternatively you can try out using this method. However, this one is more technical. So what we do here is that, okay, we realize that we have different denominators, and usually whenever we see different denominators, we would like to try and make them the same. So here what I'll do is I'll actually multiply by 1, because remember, x plus 2 divided by x plus 2, meaning if we are dividing the same things on top of each other, then that's just 1, right? Because when you think of it, 2 divided by 2, that's 1, right? But now we said x plus 2 and x plus 2. So x plus 2, you multiply that together, you get x minus 2, x plus 2, and then that's 2x plus 2. Okay, as well here, that's what you get. And then you leave 4 divided by x minus 2, right? Okay, and then from there, now it's mostly just simplification. Now remember, x minus 2 and x plus 2 are the same as x plus 2, x minus 2. So the order doesn't matter, because remember, this is algebra, and in algebra things are commutative, right? So x minus 2 and x plus 2 is the same even if the order is changed, where it's x plus 2, x minus 2. So the denominators are the same, and what happens with fractions and when the denominators are the same, we add the numerators, and that's what happened in the next step here, where it's 2x plus 2 plus 3x minus 2, and then we multiply out and we get 5x minus 2. Okay, once we get 5x minus 2, which is multiplied out, because remember 2 times x is 2, 3 times x is 5, so 3 times x is 3x, and then you say 2x plus 3x, which gives you 5x. This is 4, and this is minus 6. You add that together, it still gives you 2. It's still the same as this one over here. It's still the same as this over there. Okay, so you get 5x minus 2. But now you still have a denominator, but now you want to get rid of it, so you will multiply x minus 2 times x plus 2, right? You multiply it, and this will cross out. This will cancel each other out like that, and then you'll be left with 5x minus 2, which you see over there. And then remember, if you're going to do it on the left hand side, you must do it on the right hand side, and here you have x minus 2, you're left with x minus 2. You cross that out, and then you'll be left with 4 times x plus 2, and then that will give you the final answer of 10. Okay, so that's one of the methods that you could do. And then here we have solving quadratic equations. Now solving quadratic equations is a bit more straightforward, and again, the red highlighted ones are the ones that I would like for you to try out on your own, and then the green ones are the ones that you can see in the video. Now in the video, x squared minus x minus 12 is equals to 0. Now I have x minus 4, x plus 3, right, as the factors, because obviously when you think of it, what are the two numbers that I can multiply together to give me 12? So what are the two numbers that I can multiply together? What are the two numbers that I can multiply together that gives me 12? But those two numbers that I can add together, that will give me minus 1, right? Now you can also think of it as minus 12. So what are the two numbers that I can multiply together to give me minus 12 and give me minus 1, right? Now if you rather think of it as 12 at the beginning, and then with the sign, with it, whether it being negative or positive, you'll be informed by adding. Now where does this minus 1 come from? Remember, it comes from this one here, which is the coefficient of x. So think about this. Now 3 times 4 definitely does give us 12, right? But then in deciding the sign, I needed to find that the difference to be 1. So if I had said 4 minus 3, then it would give me 1. But now the issue is I need to choose whether or not which one will be negative and positive. So to ensure that the final answer is negative, I would say minus 4 plus 3. And minus 4 plus 3 would give me minus 1. So that's why it's plus 3 and it's minus 4. But remember the 4 and 3, just the value 4 and 3 comes from 12 because 4 times 3 gives us 12. And you can check negative 4 times positive 3 gives us minus 12, which is quite correct. Now, once you get to the step where you have your two brackets or your two factors, and we call them factors, if you have the two factors, then what you can do is you can bring them down separately and say it's x minus 4 is equals to 0, because now in this case either one of the two can result in having 0, in a sense that if x minus 4 gives you 0, if it's 0, if x here was 4, then it's 0. But you see, so if x here was 4, it would have been 0, right? This would have been 0, and this would have been 4 plus 3, which is 7, right? So it would have been 0 times 7, which is 0, right? And the second option is that if x was negative 3, right? And then that would have meant that if it was minus 7 times 0, that would have given us 0, right? So you can see that why we use or, because or basically means that it could be either one of the two or both, right? And then we have another one here, which is O. Now O, it's x into the with the bracket x plus 7 plus 10, and then we multiply in our x, and then we find it's x squared plus 7x plus 10, and then the factors is that to get to 10, I will have to multiply 2 times 5, but 2 times 5, when I add them together, give me 7. Therefore, we have our factors, which is x plus 2, x plus 5, and then we separate them, and then when we separate them, we just apply our normal solving techniques, and then we get that x is equal to minus 2, and x plus 5 gives us x minus 5. Okay, and then we move on to solving simultaneous equations, and again, the green ones is the ones that I'll do here, and then the red ones are the ones that I'd like for you to try out on yourself. So now, you're given y is equals to 3x plus 4 and y is equals to minus 3x minus 4. Okay, so let y equals 3x plus 4 to be named. You name it as saying, you give it a numerical value. You could have said it's a or b. So I say this is equation 1. So equation 1, which is y equals 3x plus 4, and then I have equation 2, which is y is equals to minus 3x minus 4, which is equation 2. And what I did was I used substitution method, right? Now, I personally would say that the best method that you could possibly use, if you master it, make sure to master the substitution method, because it is the most effective one compared to the others in terms of elimination, because some other techniques, they do need pre-knowledge. Okay, so now we're substituting. So what do I mean by substituting? That I am literally taking y, because I already have an equation where the subject is y, which is the first equation, and I'm saying literally whatever in equation 2, I am going to replace the y in equation 2 with the y in equation 1, but the y in equation 1 is equals to 3x plus 4. So that's what happened here. So then we have 3x plus 4 because I've replaced this y on this side. So it's 3x plus 4 is equals to minus 3x minus 4, and definitely from there it's quite straightforward that you get it is minus 4 over 3. And then once you got your first answer, you have to go and take it back to the first or the second equation. I chose the first equation, and then you put in the answer of x, and then you solve it, and then you find that your answers are x is equals to minus 4 over 3 and y is equals to 0. And notice something here, I said and instead of or, meaning if I'm saying and, it means at the same time, if x is equals to minus 4 over 3, it means that definitely sure your y will be 0. Okay, it's not a separate thing, unlike when we're doing quadratics where we say it is or, right, meaning that it can be either one of the two or both of them. Okay, and then we do h, and then it says given x minus 3y minus 5 is equals to 0, and 2x plus 3y plus 8 is equals to 0. And then it says okay, then I say, okay, let's have the first equation. So this equation here, which is x minus 3y is minus 5 is equals to 0. I simplify it, I get x is equals to 3y plus 5. This is the first equation. And then this is the first equation. And why did I do this? Because I remember I need to substitute. So I need to find a way of substituting quite cleanly. So I have to make something the subject, but I'm solving for it. Like I'm solving for x, or am I solving for y? In this case, here, remember, it was already in y, in terms of y. Here, it was already the subject of y, and here I made the subject to be x. So now we have 3y plus 5, that is the first equation, and then we have the second equation, which we don't have to do anything to. And then I say substitute 1 into 2. So literally, I take 3y plus 5 and replace x, right? Because this is the equation here, the subject of this equation here is x. So I'm replacing this x with 3y plus 5, and then I just solve it as I'll normally solve a equation. And as you solve it, you'll find that your answer would be y is equals to minus 2. And then I take that minus 2, and then I replace it, and I'll get minus 1 as our answer. And therefore, you have that x is equals to minus 1 is equals to, and y is equals to minus 2. And remember, they go together because it's and, right? Okay. And then we have what we call literal equations. Now, literal equations are just formulas that we need to be able to convert from one variable to another. So in this case, we'll look at D and F. So this is a compound interest formula, and this one is a kinematics motion formula, which you'd find in physics, and this one you find in maths and finance. So they want us to get I, and here they want us to get A. And so basically for I, what you do is you just divide by P. You just solve it as you would normally solve a general equation. So I divide, this cancels out. Then I'm left with 1 plus I all to the power n. So since it's 1 plus I all to the power n, I multiply it by 1 over n, because you would note from here that why I can multiply 1 divided by n as an exponent. And remember, whatever I do on the left hand side, I must do on the right hand side. Therefore, now I also do on the other side. So we'll have a over p all raised to 1 over n, right? So then from there, this cancels out, and then you're left with 1 plus I, right? So if it's 1 plus I, and remember, this is just also a. So if it's 1 plus I, then I want I just take the 1 onto the other side, and that means that it's going to be a over p all raised to 1 over n minus 1. That is equal to I. And you can just rewrite it the other way around, where you put I on the left hand side, and then you have your answer. Okay. And then the F, yeah. So now you have F, and F is a kinematics equation, which describes linear motion or quadratic parabolic motion of objects. So you have S, which is distance, is equals to U, velocity, time, plus 1 over 2 acceleration, and time again to the power 2. And they want the acceleration, which is A, right? So here it's actually more simpler compared to the other one. So you just take ut and subtract it by s, subtract s, so it's s minus ut, and then you have half over at squared. Now remember, half at squared can also be seen as at squared divided by 2, right? So if that's the case, then I can multiply it by 2 over t squared, because what will happen is that t squared at the bottom will cancel the t squared at the top, and the 2 at the top will cancel the 2 at the bottom. But whatever I do on the left hand side, I also must do on the right hand side. So now I'll have 2 over t squared times s minus ut, right? And basically that would be 2 and this we can still rewrite, same idea as this one from here to there. You can still rewrite as 2 on the bracket s minus ut, or divided by t to the power 2, which is equals to the acceleration. But then we can just rewrite it again and say the acceleration is equals to 2 in the bracket s minus ut, and then all divided by t squared. Okay, so that's literal equations where you just need to be able to rewrite the equation into you need to be able to make one of them the subject of the formula. Okay, and then we have solving linear inequalities, right? Now solving linear inequalities is still the same as equations, but the only difference now, it's the meaning of the final answer. So the meaning of the final answer, right? So you'll see what I mean by that. So now it says 3x plus 4 is less than 5, right? So when we do just normal equations, we'll take 4 onto the other side, so it would be 5 minus 4, that would give us 1. But then since it gives us 1 and we have 3x, we can divide 3x on both sides and it will give us 1 over 3. So now it actually says x is less than 1 over 3. But what does this mean in literal fact? If you think of a number line, if you place here 1 over 3, this literally meant that we have an open circle, meaning that it is not included. And when I mean by included and not included, included means it's a closed dot like that, where we have less than or equals to. If there's equals to, then it's closed, right? And it's included. If there isn't any equals to, which is just less than, less than. If it's just less than, that means it is not included and it's an open circle. Now what does it mean? Imagine this number line, right? This is to negative infinity, right? And this is also to positive infinity. So you have 1 over 3 here, and we are saying x is less than 1 over 3. That means that all the numbers from 1 over 3 supposed to be less than it, right? And that's what it means. Unlike when you say x is equal to 1 over 3, then that literally means that my x can only be equal to 1 over 3. But here it's saying I can be equals to any number that is less than 3. And what does that basically tell you? It basically tells you that for all the values that are less than 3 are correct for this particular equation, in such a sense that if you chose negative 10, it still satisfies this inequality and it would be correct. Okay, so that are inequalities, but here's another way of looking at it, and this is known as the interval notation, where it says x is an element of negative infinity to 1 over 3, right? And notice the brackets, they are open brackets, and these open brackets just basically mean that they are not including the literal number. So 1 over 3 is not a solution. So in this case, when we say x is less than 1 over 3, it means that it is not a solution, but is a starting point where we do not include 1 over 3, but anything smaller than 1 over 3 is the solution, right? Okay. And then we have another one, which is g, and so you would do the same ideas. You would do distribution, and then you distribute, and then you find your answer, then you simplify, and then you find that it's 7x minus 23, that is less than minus 2, and then you divide and you find that it is 3, right? And the same idea applies. But in this case, now it says x is less than or equal to 3. Hence, that means that where it's 3, it means that it is included, and you would have drawn the number line in this manner, right? So you would have drawn the number line with this manner, right? And in interval notation, that means it's x is an element of negative infinity to 3 that is included, right? That is included, meaning now we are including 3, and everything else that is comes off after it, right? Something that you should notice is that when we use this particular notation, whenever we're talking about any infinity, whether it is positive or negative infinity, you will always use an open bracket. Always use an open bracket. Whether it's positive or negative infinity, you always use a open bracket. Always use it, because infinity, we don't know what infinity is, so you can't include something that you don't know. You see, it makes sense. Okay, that is the video. I thank you for watching this video, and I hope this was helpful. Other than that, I'd like to see you next time. Thank you, good luck, and goodbye.